Good day, grade 11 learners. Welcome to today's Life Sciences lesson. My name is Susan Wiese. This lesson is brought to you by Gauteng Department of Education in collaboration with Sibona Discovery Centre and broadcast by Pakama Research and Development. Today we're going to look at homeostasis. Now I know, grade 11s, if you think back, you're going to tell me there was no chapter this year called homeostasis. And you're quite correct. There wasn't a chapter called homeostasis in your grade 11 life sciences here. But you dealt with that within some of the topics. And you dealt with it when you did the digestive system, when you did the breathing system, and when you did excretion by the kidneys. So let's get into today's lesson. First of all, what is homeostasis? Homeostasis refers to a process of maintaining a constant internal environment within narrow limits, despite changes that take place internally and externally. The internal environment refers to the blood and the tissue fluid that surrounds the cells of the body. And how is this done? By means of a negative feedback mechanism. A negative feedback mechanism operates in the human body to detect changes or imbalances in the internal environment and to restore the balance. It stabilizes a system and returns it to its normal state. Please look carefully. The very last sentence is bolded. And why is this? Whenever you are answering a question based on homeostasis, this is your last sentence because that is the reason why homeostasis is taking place. It's taking back whatever was incorrect to the normal state or the normal level. Now, if we look at our diagram, you can see that, remember, the blood will be found where? In your arteries and in your veins. And between an artery and a vein, we find the capillaries. And as the blood moves through these vessels, they do leave the vessels and surround the cells in our body. And that is called tissue fluid. Now, it's very important for our bodies to have an internal environment that is stable so that it can function optimally. What is this negative feedback mechanism that we are referring to? Negative feedback mechanism control each of the following in the body, and you have only learned about the following this year. You have learned about blood glucose levels, and you did this when you did the digestive system. Then you also looked at blood carbon dioxide levels, and this you studied when you did the breathing system. And then you also looked at osmoregulation when you did the excretion by the kidneys. And osmoregulation involves two components. It involves water and it involves salt. Now, a negative feedback mechanism always happens in 7 steps. And it's important that you know the sequence of these 7 steps. First of all, an imbalance is detected. So there must be something in your body that is picking up that you know what, the environment is now changing. And remember, you only looked this year at glucose levels in your blood. You looked at CO2 levels in your blood. You looked at water and you looked at salt. And then a control center is stimulated. So first of all, there's a detection of something is now wrong. And then that message is sent to a control center. The control center responds. That is our step number 3. The message is then sent to a target organ or organs. It can be more than one. The target organ responds. And then it opposes or reverses the imbalance and the balance is restored. Once again, please remember your very last step. Whenever you are writing or answering a question on homeostasis, it is very important for you to have that very last sentence because normally a mark is allocated to this sentence. Terminology at this stage, there are 3 terms that is very important for you to remember and to understand. The first one is the difference between an endocrine gland and an exocrine gland. All right, an endocrine gland is a ductless gland. So that there's a gland where there's no little tube. And that gland is secreting hormones directly into your bloodstream. All right. An exocrine gland secretes substances into ducts. So they have little tubes that lead into cavities in the body or lead directly to the external environment. And examples of exocrine glands are the sweat glands, the mammary glands, the liver, the salivary glands, and the pancreas. And then hormones are organic chemical messengers secreted directly into the blood by an endocrine gland. So an endocrine gland and a hormone is working together. And I'm giving you a hint. Please remember, there's only one organ in your body that is both endocrine and exocrine, and that is your pancreas. Because the pancreas is secreting hormones, insulin and glucagon, that you have studied, then it acts as an endocrine gland. But when the pancreas is secreting pancreatic juices, that goes into a duct and it goes to your digestive system. So then it acts as an exocrine gland. So to sum up, because this is very important, what the differences are between an endocrine gland and an exocrine gland. Remember now, an endocrine gland is ductless. So there's no little tubes and secretes directly into your bloodstream. And what is being secreted? Hormones are secreted. All right. And then an exocrine gland is secreting their substances into ducts. So they are little tubes and not the bloodstream. And then, like I said, think of the salivary gland secreting saliva in ducts that's transported then to your mouth, for instance. And no hormones are being secreted. All right, so it's very important for you to remember this. And I'm sure you have stumbled across the terms endocrine gland and exocrine gland this year in your grade 11 life sciences year. Now, if we look at this diagram, you will see that these diagrams show where some of the glands are situated in your body. And it's important for you to have this diagram here in your head. So when people are saying the pancreas, you must know more or less where is that in your body. If somebody is talking about the hypothalamus, then you must know where that is. So it's important that when you study this diagram, is to associate the positions of the glands within yourself. I normally say, when we're doing human biology, I think that's one of the easiest chapters to do, because you're actually sitting with a textbook, because you're studying your own body. You're studying what is happening in your own body. So when you study this, think of, all right, it's situated here, or you know what, no, that's the one in my throat, or around in my neck, or that's the one in my abdomen. So that's important for you when you look at this diagram. Now I'm only going to highlight the organs, or the glands rather, some of them that you have studied this year. And next year you will learn about all the others. First of all is the hypothalamus. Now the hypothalamus is situated here in the brain, and that's actually part of your brain. And the gland that is associated with the hypothalamus is the pituitary gland. Now, can you see the pituitary gland is that small little structure that we have there at the bottom of the hypothalamus. So when somebody, or when you read about a hypothalamus, you must immediately know, all right, that's the part of my brain. And the hypothalamus, at the bottom of the hypothalamus, there's that small little gland called the pituitary gland. All right, so that's the first one that's very important. And you have stumbled across the hypothalamus this year, because the hypothalamus is secreting ADH. Now, ADH is a hormone that helps with osmoregulation, and it controls the water levels in your blood. The thyroid gland that you see here is a gland that you have not studied this year. But next year, you're going to add the functions of the thyroid gland to your knowledge of homeostasis and the endocrine system. But please remember this so long. Where's the thyroid gland in your body? It's situated in your neck. All right, so it's more or less around here in your neck. That is where you will find your thyroid gland. And next year you will learn about the hormones secreted by the thyroid gland and the effect of that on your body. Then the next one here is the pancreas. It's very important that you know the structure, or rather the outlines. How does it look like? How does your pancreas look like? Because in many instances, the examiner can only give you a line diagram of the pancreas, and then you must be able to identify or to recognize that. So it's important for you to know more or less the outlines of the pancreas. And the pancreas, like I've already indicated to you, is the only organ in your body that is both an endocrine gland and an exocrine gland. And the reason for that is when the pancreas is secreting the hormones, insulin, that you have studied this year, and glucagon, it is acting as an endocrine gland. And when the pancreas is secreting the pancreatic juices, then it is an exocrine gland, because then those juices are actually moving into ducts to the digestive system where they play a role. Then the ovaries and the testes, you have not studied this year. You will do this next year when you study the reproductive systems of the male and the female, and then you will learn about the hormones secreted by the ovaries and the testes. And then we get to the adrenal gland. Now the adrenal gland secretes two hormones. The adrenal gland, first of all, where is it situated? It sits like a little hat on top of your kidneys. All right. So please make sure that you know exactly where the adrenal gland is situated, and it's secreting two hormones. The one is adrenaline, that you have not studied this year, and next year you will learn about adrenaline and the functions of adrenaline. And then aldosterone is the other hormone secreted by your adrenal glands, and that you have studied this year when you did the excretion by the kidneys, because the aldosterone is playing a role in the salt concentration. It helps to regulate the salt concentration levels in your blood. So this is a very important diagram. Examiners can ask you to identify the glands and the organs, and they can also ask you then to state which hormones are secreted by them. So make sure that before you go into grade 12, that you know this work very well, so that when we go into grade 12, it's not something you have to go back and study again. All right, now we're going to look at the first homeostatic control that you have studied this year, and that is the control of your blood glucose levels. If we look at, first of all, what happened to my blood glucose levels when I've eaten. If you had breakfast this morning, then what I'm going to say now is exactly what's happening in your body. After a meal, your blood glucose levels will increase because you've taken in some glucose, because more glucose is absorbed from the small intestine into the blood. The pancreas detects an increase in blood glucose and releases the hormone insulin, which causes the glucose to be converted into glycogen. Now, it's important in this chapter that the spelling of the words are correct. The spelling of glycogen, glycagon, glucose is very important. If you spell those words incorrectly or you mix them up, then you're going to lose marks. So this is one chapter in life sciences where the spelling is very, very important. So you have to pay attention to that. Then glycogen is stored in the liver and skeletal muscles in the body. The body cells are also stimulated to take up glucose. This lowers the blood glucose level and returns it to normal. Remember my sentence, my very last sentence always. when I'm looking at homeostasis is and returns it to normal. All right, so that's very important that you remember that. Now let's look at our diagram. If we have a raise in blood sugar, so we're starting basically here. So after this morning, after you had breakfast, whatever you had, whether it was starch, whether it was something sweet, there will be glucose in your digestive system. Because remember, starch is also broken down to glucose. You did this when you did the digestive system. So if I've eaten something this morning, it means that my blood sugar will increase. All right, so my blood sugar was low when I got up this morning, so I've eaten something, and now my blood sugar is actually going to increase. So if my blood sugar increase, who will detect that in the body? Remember those 7 steps that I referred you to when we started. So what is happening? What is the imbalance? My blood sugar levels were low or normal, and now suddenly there's an increase. All right, so that's abnormal. I want to bring it back to normal. So what is the detector here? It's the pancreas. So the pancreas will detect that, you know what, I see now the blood that's going through me, there's an increase in the blood sugar levels, the glucose levels. So what is happening then? Because it's high, the pancreas will secrete insulin. That's the hormone. And the hormone will have 2 functions. It's going to do 2 things to bring my blood sugar that was up high back to normal. The one is it will stimulate glucose uptake from the blood by my cells. So my cells will be stimulated to take up this glucose that I've just eaten or taken in, so that they have energy for respiration. But let's say I have taken in too much glucose this morning. All right, I had a big plate of porridge with lots of sugar and milk, and actually now I have too much glucose in my bloodstream. So what is going to happen to that excess? You know, the too much. What is going to happen is in the liver, this organ here is your liver. In the liver, the glucose will be converted to glycogen. Glucose will be converted to glycogen. Remember what I said about spelling. Glycogen has got an E here at the last part. And then if glucose is converted to glycogen, it can be stored in the liver. All right. For in case later in the day I need that again, then it can be broken down again, or then it can also, from glycogen, you can go back to glucose. All right. So that is happening when you have an increase in your blood sugar level. So after you've taken in something, whether it's starch or it was something sweet, and it's broken down to glucose, and now the blood is taking it up, the first thing that happens is the pancreas is saying, hey, wait a minute, there's now suddenly a high increase in the blood sugar levels. So what does the pancreas do? The pancreas secretes insulin. So you must remember that when your blood sugar levels are high, to bring it down, the hormone for that is insulin. And how is that done? The insulin will stimulate the cells to either to take up some of those glucose so that you can use that for respiration in your cells, and then the excess glucose will be converted to glycogen in your liver, and it will be stored there so that it can be used at a later stage. Now, let's say you're on a diet and now you're not taking in any glucose. All right, so what is going to happen now? Your blood glucose levels are going to drop because there's no blood and there's no glucose being taken in by the body. Your blood glucose levels will decrease because the body cells are constantly using glucose for cellular respiration. That is something that you must remember. All right? Our cells are busy with cellular respiration, and for that they need glucose so that they have energy. When blood glucose levels decrease, so when it's going down, the pancreas, once again, is actually the policeman here, will release the hormone glucagon. All right, spelling important. Glucagon, which converts that stored glycogen that we have in our liver and our skeletal muscles back to glucose. This increases the blood glucose level and returns it to normal. So can you see it's almost the opposite of when your blood glucose levels are high. So if we look here, if the blood glucose levels are high, no, it's actually low. What is going to happen? The pancreas is going to detect that. So once again, the pancreas is the policeman here. The pancreas is detecting, wait a minute, this person hasn't eaten for quite some time, and the cells are using the glucose, and now suddenly there's a drop. It's below normal. So what does the pancreas do? The pancreas is secreting the hormone glucagon. All right, a name that you must remember and must spell correctly. Glucagon. What does glucagon do? Glucagon goes to the liver, and in the liver, remember, there are stored glycogen. So that glycogen that we stored there because of the food that we ate earlier will be converted back to glucose. And if there's glucose being put into the bloodstream, what will happen? We will see a definitely raise or our blood sugar levels going up. All right, and this is how your blood sugar is being controlled in your body. Remember we said, what is homeostasis? It's the process to keep the internal environment of the body and the cells constant, no matter what happens inside or outside the body. If we look at this diagram, here you can see everything at once. Here we have, this is what we're aiming at, to have normal glucose levels all the time. But if there's an increase in our glucose levels, let's start here. If there's an increase, so you've eaten something or you drank something, what will happen? First of all, what will happen is the pancreas, important, that is almost like the police that's going to say, hey, wait a minute, something has happened here. And then now because of the blood sugar level that is high, what will happen is that there will be a secretion of insulin, and that's the hormone. So insulin actually do two things. Insulin, first of all, stimulates the cells to take up this excess glucose, and then if there are too many glucose or too much glucose, the glucose is converted to glycogen. And where does this happen? It happens in our liver. So you must know the organ. And then the glucose levels will decrease because you're taking out the glucose levels from the blood. Now, if the glucose levels decreases, that is now if, let's say, you haven't eaten for quite some time, and now suddenly there's a drop in your glucose levels, who will be the policeman? The pancreas. The pancreas is the policeman, and the pancreas will do what? Remember now, the blood sugar is too low, so we must get it up. So what must happen? The hormone glucagon, remember, spelling important, glucagon is secreted. What does glucagon do? Glucagon goes to the liver, and what does the liver do? In the liver, that stored glycogen that we have there is converted back to glucose. And when it's converted back to glucose and put into the bloodstream, we will see an increase in our blood sugar levels. All right, you can also look at the diagram. There's that little cake, and if you eat that, definitely you're going to have an increase in your blood sugar levels. Because of that, the pancreas is going to secrete insulin to bring it down, and then it will lower the blood sugar level. And if there's too much, remember what happens here in the liver? The glucose is converted to glycogen and stored there. And then the opposite, if your blood sugar levels are low, all right, you haven't eaten, can you see there's nothing here, nothing has been eaten, the pancreas will detect if the blood sugar levels are too low, and then it will release the other hormone, glucagon. All right, spelling important. What does glucagon do? Glucagon stimulates the conversion back of glycogen to glucose, and then the blood sugar level will rise. Now, if you have a constant high blood glucose level, so your body just can't get it down, it keep on staying high, you can develop the disorder called diabetes mellitus. All right, now diabetes mellitus, if we look at the symptoms thereof, how do I know I've got this? Excessive thirst. So this person is thirsty all the time, drinking a lot of water, drinking a lot of fluids, although you haven't exercised or it's not really very warm, but you're always thirsty. High blood sugar, so you can test and you'll see that your level of glucose in your blood is constantly very high. You might experience weight loss. So without being going on a diet, suddenly you're just losing weight. And it could be also because of the fact that you're drinking so much liquid the whole time. You can be fatigued, all right? So you're very tired all the time. If you have a wound or a cut, it heals very slowly, and it can affect your eyesight. So you might have blurry eyes, all right? And obviously then frequent urination, all right? But because why are you frequent urinating? Because you're taking in all this liquid the whole time. How can I prevent this? How can I prevent that my blood sugar levels is constantly high? Exercise, that's important, and you need to look at your diet. You need to take in healthy foods, vegetables, fruit, and not so much starch and fats. And then obviously, if you do have this disease or disorder, you can take medication, and sometimes it's necessary for these people to inject themselves with insulin because of their high blood sugar levels that stay constantly high. Now, there are two types of diabetes mellitus. If we look at diabetes mellitus, you get type 1 and you get type 2. Many people have got type 2 diabetes mellitus. Type 1 diabetes is caused usually an inherited disorder or a loss of insulin-producing cells in the pancreas. So that is where your body has actually lost the possibility to secrete insulin. All right, so somehow in the pancreas, the cells that were supposed to secrete insulin is not working, and therefore you have this constant high blood sugar levels. How do we treat this? It is treatable. Lifelong disorder that requires daily injections of insulin and specially adapted diet. So you're not going to get rid of this. If you are a type 1 diabetes person, that's a disease that's going to stay with you for the rest of your life. And for the rest of your life, you will have to look at your diet, and then if necessary, you will have to inject yourself with insulin for the rest of your life. Now, type 2 diabetes, like I said, many more people or much more people actually have this disorder. How is it caused, or what is causing it? Insulin resistance. So you will hear people will say, but I'm insulin resistant. If somebody tells you that, then you must know that person is actually a type 2 have type 2 diabetes, where the body does not produce or react to insulin. So that's important. It doesn't react to insulin, usually as a result of a poor lifestyle choice. All right, we will look into that just now. Treatment, how can I treat this? Maintaining a balanced diet. So people must watch their diets. You must regular exercise. All right, and I think many South Africans, that's where our problem is. We're sitting behind our computers, we're lying on the couch watching the TV, but we don't really exercise. And exercise is not, you have to run every day, or you have to go to the gym and weight lift every day. No, you can just go for a walk. And that is something that all of us can do. But do we do that? That's the question. And then obviously people that have type 2 diabetes also take medication to help them to control actually their blood sugar levels. Now, if we look closely to type 1 diabetes, now here in this diagram you will see there's a healthy person's reaction in the body, and at the bottom we have type 1 diabetes. Now, if we look at the healthy person first, see, there's glucose being put into the bloodstream. All right, there's glucose put into the bloodstream, and because of that, we have insulin secreted by the pancreas. So what is happening? Glucose is stored and or used in the organs. So there's enough. Can you see here? There's a normal level of glucose in the blood. Remember, you must have glucose in your blood. Can't be zero. There must be glucose in your blood. Why? Because the cells are busy respirating, and they need that glucose for the process of respiration. Now, what happened in a type 1 diabetes person? Glucose still is being put into the bloodstream, but less insulin is secreted. If you look at the green arrows, you will see, if you compare the green arrow on top with the green arrow at the bottom, you can clearly see that the amount of insulin secreted is far less in a person that is type 1 diabetes. Sorry for that. Now, if we look at what is happening here in the cells, less glucose being stored and or used in the organs. All right, so less glucose is stored and used. So what is the result of that? There, can you see the difference? If you look at the top diagram here and you look at the diagram at the bottom, there's an increase of the glucose levels in the blood. So that is with the type 1 diabetes. So with type 1 diabetes, the problem is not enough insulin is being secreted by this person. And therefore, people that have this disorder must inject themselves with insulin to help the body to bring down the glucose levels. Now, if we look at type 2 diabetes, once again, there we have a healthy person, and then here's the type 2 diabetes person. What is the difference? Same as in diabetes type 1, in the healthy person, glucose is being secreted or actually absorbed in your bloodstream. Insulin is secreted, and there you can see you have a normal level of glucose in a healthy person. But even in a person that's type 2 diabetes, what happened in that person? In that person, insulin is secreted, but can you see this insulin and the insulin there is exactly the same? So there's nothing wrong here. Insulin is being secreted, but the problem comes in what that insulin is doing. The organs are now unresponsive. They don't want to respond to this insulin. So less glucose is being used or stored. And what is happening? We have an increase then of the glucose levels in the bloodstream. So that's the difference between diabetes type 1 and diabetes type 2. Now, diabetes type 1, that is where insulin secretion by the body is just not enough. But by diabetes type 2, that is where insulin is being secreted, but the organs and the cells of the body doesn't want to respond to this insulin because it's supposed to take up the glucose and to convert the glucose, and now it's not happening, and that's why that person has got a high blood sugar level. Causes of type 2 diabetes, high blood pressure, so it can lead to type 2 diabetes, pancreatic diseases, obesity. So people that are very, very overweight, that can lead to type 2 diabetes. Age, so we find this more in older people. Genetic predisposition, stress, so stress levels is not good. Sedentary lifestyle, all right, that's when you're not moving around a lot. So you rather lie on the couch than kicking the ball outside. You rather drive to the cafe than walking that 1 kilometer to the cafe and back. Unhealthy food, if you have too much of unhealthy food, that can lead to diabetes type 2, and then also some medication can also cause diabetes type 2. All right, so many South Africans are actually suffering from diabetes type 2, and that is because of the lifestyles we have. We eat unhealthy food, we don't exercise, we have a lot of stress, and that, or an age as well, and then that can cause that we have type 2 diabetes. But that is treatable. You have to look at your diet, you have to exercise, and if necessary, you have to take some medication. All right, now let's look at questions. If this is everything I have to know from grade 11, what can they ask me about this? And this is the things that you need to know now, because this is what you've studied in grade 11. So you must be able to answer the following questions. First of all, The graph below indicates the effect of glucose concentration on insulin production before and after a meal, measured for a healthy person over a 2.5-hour period. All right, don't even look at the questions yet. We must first look at the graph. So they're telling us this is a healthy person. So this person, it means that the insulin secretion is working normally. And they say that they're showing us it's for 2.5-hour period, so they've measured it for quite some time, and they say it shows the effect of glucose concentration on insulin production. All right. Now, if we look at the questions, they're asking us during which period of time, so we must read time, was the person's blood glucose level constant. Now, if we look at the graph, there are two lines and they're giving us a key. Glucose is the solid line and insulin is the dotted line. All right? So glucose is, which one is the top graph? And insulin is the bottom graph. So they're asking us during which period of time was the person's blood glucose level constant. So at which graph are we looking? We are looking at the top graph. Now, if you look at the graph, where was the graph showing you a constant value? Yes, I'm sure you can see that. It's from 7 o'clock, here, 7 o'clock, up to 8 o'clock, isn't it? So between 7 and 8, because that's where the line is horizontal. And that means if you read here, the glucose level stayed at 60 milligrams per 100 milliliter. Then if we look at question 2, what is the glucose level in the blood at 9 o'clock? Can you see this is a skill? You can't study for this. Remember when we looked at skills on Monday? So now you must be able to read off the graph. What is the glucose level in the blood at 9 o'clock? Please use a ruler in the exam. Don't just, say, oh, it's more or less. No, take your ruler. And then 9 o'clock is down here. Where is 9 o'clock? Here is 9 o'clock. So what are you going to do? You're going to put your ruler here and you're going to read, and they want to know the glucose level. So we're going to go up all the way up to there. And that is what we need to read. And remember, you're going to give a value plus a unit, because on the y-axis there's a unit given there. And that is the unit that you must also use in your answer. So it's 93 milligrams per 100 milliliter. All right, and normally in the exam or in a test, we will give you 1 mark for the value and we will give you 1 mark for the unit. So don't throw away that 1 mark for the unit. Make sure that you include that in your answer. And then they're asking us, describe the homeostatic control of blood glucose levels after eating breakfast at 8 o'clock. All right, so you can see this person was eating breakfast at 8 o'clock. How can we see that? If we look at this person's blood sugar levels, we can clearly see there was an increase there. And then from there, from about 8:45, 8:45, the blood sugar was coming down. All right. Now you must describe that. So how are we going to describe this? You're going to say because of the glucose, because of the breakfast that was eaten there at 8 o'clock, the glucose levels in the blood will increase. And then if the glucose levels in the blood increase, what organ again is being stimulated? Who's the policeman here? Who's picking up that suddenly there's now an increase in the blood sugar levels? Do I hear that? Yes, the pancreas. So the pancreas is picking up that the blood sugar level is increasing. What is the pancreas going to do? It's going to secrete which hormone? You know there's two. It's either insulin or it's glucagon. So which one is now involved here? It is definitely which one? Insulin. So each insulin is secreted. What does insulin do? Two things. One is it will stimulate the cells to take up the glucose. And the other one is it will do what? It will in the liver convert glucose to glycogen. Remember, spelling important here. And that is the format in which the excess glucose will be stored. Let's see if our answer is correct. After eating breakfast, what will we see? Yes, the blood sugar level increases. We've said that. The pancreas, important, is stimulated to secrete what? Insulin into the blood. It's important that you say that because remember, this is now an endocrine gland. So it is secreted into the blood. Insulin stimulates the absorption of the glucose from the blood, stimulates the conversion of glucose to glycogen, which is stored where? In the liver or the muscle cells. Blood glucose levels are decreased back to normal. Remember what I said? Whenever you're doing a homeostasis question, this last sentence is always there. You must say, and then the level is restored, or it's taking it back to normal. All right, that's very important. If we look at the fourth question, describe the expected changes in insulin levels if this person was diabetic and untreated. So remember, this is a normal person, and as you can see, insulin is following glucose, because if the glucose levels are high, then we see an increase here. But now, what if this person is diabetic? If this wasn't a normal person, what will happen to this person's blood levels? Describe the expected changes in insulin levels. How will his insulin levels be changing if he's a diabetic? Insulin level will not rise after the meal, would stay the same and would remain relatively low. Because remember, what did we say? A type 1 diabetic person, what is wrong there? The body can't secrete enough insulin or doesn't secrete it at all. And that is why the insulin levels will not rise as here. It could rise a little bit like there, all right, or even nothing. So it would have stayed here at the same level. All right. Our next question, study the graph and answer the questions that follow. Now first study the graph and then we look at the questions. The graph, what do we have? We can see there in the morning this person has breakfast, and in noon there was lunch, and then in the evening there was also dinner. All right. And can you see there are two lines again? The blood sugar is the black line and the blood insulin is the brown line. So let's see. After breakfast, what happens to the glucose levels? We can see a clear increase. There is an increase there. What happens to the insulin? We see an increase. All right. And it's coming down. And the same happens every time this person has eaten. Let's look at the questions. What happens to the blood sugar level every time this person eats a meal? What happens to the blood sugar level every time this person eats a meal? We've just said we see the blood sugar or the blood glucose level is increasing. It increases, all right? Why does the insulin level only increase after the glucose level increases? So, because if you look, you'll see that after we have that increase there, we see an increase here in the insulin levels. Why is that every time after you've eaten? Because what is being absorbed after you had a meal? Glucose. So what will happen to the blood sugar level? It increases, it stimulates the pancreas to secrete what? Insulin. And then because insulin is secreted into the bloodstream, you see the rise. Let's check our answer. Increase in blood glucose stimulates the pancreas to secrete insulin. Question 3. What does the straight line represent? Can you see there in the middle? We have a straight line, horizontal line. If I draw it there, there's our straight line. What is that? That is showing you what? The normal glucose levels. All right. So that is the normal blood glucose levels. So the minute it goes above that, that is where we will have the secretion of insulin in this case. And if it goes too low, what will happen? Glucagon will be secreted. Then they say, describe the effect that insulin has on the glucose levels in the blood. I think we have answered a question like that just now. Let's see. Yes, insulin stimulates the conversion of excess glucose into glycogen in the liver, thus lowering the glucose levels in the blood to normal. All right. Let's quickly read this extract. Diabetes, treatment and management. Two forms of diabetes are found in humans, namely type 1 and type 2. With type 1 diabetes, the body's immune system mistakenly sees the insulin-producing cells in the pancreas as foreign and destroys them. Okay, so there is no pancreas-secreting cells. People with type 2 diabetes are able to produce some of their own insulin. Often it's not enough. Overeating, especially of foods rich in sugar, causes repeated stimulation of the pancreas, which responds by secreting large amounts of insulin. The excess insulin decreases the target cell's ability to respond to insulin. Treatment focuses on diet and exercise. Now let's look at our questions. 1. Name one body fluid that can be used to test for the presence of excess glucose in the body. So where will you test? What body fluid can you use to do that? Yes, you can use the blood. And then what else? If you have too much glucose in your blood and the body can't get rid of it by converting it to glycogen, where will that excess go? It goes to the kidneys. And finally, it's going to end up where? In your urine. So you can use urine as well to actually test for blood sugar levels. Then they ask us, give 2 target cells. So how many must you give? 2. In the human body, that will be affected by an excess of insulin. So if you have too much insulin, 2 target cells that will be affected. It will be your liver cells and also your muscle cells. And then explain the consequence for type 1 diabetics when the immune system destroys the insulin producing cells. All right, and I think we have looked at this. The body cannot reduce blood glucose level, therefore they have to inject themselves daily with insulin. All right. And then our last question. Here it's a little bit different. They give us here a flow diagram. Okay, and looking at this diagram, before we look at the questions, what must you be able to recognize? What is this? Remember I said, this is one of those organs that you need to know the outlines. You know, how does it look like? And this is your what? This is your pancreas. The liver, they have labeled for us. And then they want us to say which hormones are released. And you know the pancreas is releasing what hormones? 2 of them. We know it's insulin. We know it's glucagon. And then they want us to say, no, and then they're just showing there's an increase in the blood sugar level and there's a decrease in the blood sugar level. Now, let's look at the questions. They want us to identify organ 1. We've already done that. That is our pancreas. Now they want us to identify hormone 2 and hormone 3. Now let's look at the diagram. If I have a high level of blood glucose, there's a high level of blood glucose. All right, that's the dotted line. Which hormone will be released by the pancreas? A high level is insulin. All right, so that is insulin. And then if we look at number 3 is saying, and that's the solid line, if low levels of blood glucose are detected, what is going to happen? Which hormone is going to bring back the glucose levels? It is glucagon that is secreted. And then they want us to say, number 4, the disorder caused when organ 1 fails to release sufficient amounts of hormone 2. If the pancreas can't release enough insulin, what do we call that? Diabetes mellitus. And then the mechanism that controls the levels of glucose in the body, what mechanism is that? Negative feedback mechanism, or you could have said homeostasis. All right, that's the one that you have covered this year, is the homeostatic control of blood glucose. Now let us look at the homeostatic control of carbon dioxide levels. Now carbon dioxide levels, so if I say that, you must immediately think of what? Your breathing system. Now if we look at the breathing system, you will notice that we only look at high carbon dioxide levels. Why not low carbon dioxide levels? Why are we only looking at high? Because that's the only one that's dangerous. If you have low carbon dioxide levels, it means that you will have high oxygen levels. And if you have high oxygen levels, that's brilliant, because oxygen is what you need for respiration. So, and for your cells to really, work. So it's not bad for the body if we have high oxygen levels and low carbon dioxide levels. But what is bad for the body is if your carbon dioxide levels are high. Now, when are they high? Normally, when you're busy training or exercising, you will experience that suddenly my breathing rate is increasing, my heart rate is increasing, and that is when you must know that your carbon dioxide levels are actually high. So, what is here? Let us quickly look. First of all, the stimulus is that increase in the CO2 levels. All right. Who now is the policeman here? The policeman here is the carotid artery and also the walls of your aorta. They will, and because of the CO2 levels that are high, there will be a decrease in the pH of your blood. So your blood will now turn to be acidic, and there will be a decrease in your oxygen levels. The receptors are stimulated, and they are chemoreceptors, and they will stimulate this low pH level. The control center is the medulla oblongata, and the medulla oblongata is situated near your brain. We will look at that just now. And what will happen? The medulla oblongata is sending a message to where? To your breathing muscles. And you have two types of breathing muscles. You have your diaphragm and you have your intercostal muscles. And they will suddenly start working faster and also will increase the depth of breathing. So you will exhale more, inhale more air, and not just swallow breathing. And then your heart muscles will also receive an impulse to say, you better start working faster. So your heartbeat will increase, you will start breathing much faster, so that it's possible for you to take in more oxygen and get rid of the excess CO2. So the heart rate will increase, more CO2 removed from the body, and then the negative feedback is the blood CO2 levels fall, so the pH will return to normal. All right. So once again, remember those 7 steps that we started off when we said, how does a negative feedback mechanism work? You have to apply it here as well. Now, let us quickly look. When the carbon dioxide levels in the blood increases, so it's after or during exercise, there is the policeman, the receptor cells, and we said it's chemoreceptors in the carotid artery and the wall of aorta will be stimulated. What do they measure? They look at pH. They look at the pH of your blood. They send impulses to the medulla oblongata in the brain. The medulla oblongata stimulates the breathing muscles. And please, if you write breathing muscles, it's fine. But otherwise, if you want to name them in an answer, you have to give both of them. If you just say the diaphragm or you just say the intercostal muscles, you're not going to get marks. All right, so you have to mention both of them. So you must say impulses are sent to the diaphragm and impulses are sent to the intercostal muscles so that they then work harder. And also to the heart, because the heart must now beat faster. Breathing muscles contract more actively. All right, increases the rate and the depth of breathing. The heart beats faster. More carbon dioxide is taken to and exhaled from the lungs. The carbon dioxide level in the blood returns to normal. Remember our famous last sentence? The carbon dioxide level in the blood returns to normal. All right. You must have that sentence to get your full marks whenever you're answering a question on homeostasis. So remember what I said? We are looking here at what? We are looking at only high CO2 levels, not low CO2 levels, because that's not bad for the body. If we quickly look at the steps, if we want to place what is happening in the 7 steps, when the CO2 level in the blood increases, all right, so now the CO2 is high, what is happening? The CO2 levels in the blood increases above the normal levels. Step 2, receptor cells in the carotid artery in the neck are stimulated, and also the walls of the aorta, to send impulses to the medulla oblongata in the brain. The medulla oblongata stimulates breathing muscles, which is your intercostal muscles and your diaphragm and your heart. Breathing muscles contract more actively, increases the rate and depth of breathing. The heart beats faster. more CO2 is taken to and exhaled from the lungs, and step 7, the CO2 level in the blood returns to normal. And I've asked you this question: where is your medulla oblongata? Do you know in your body where your medulla oblongata is? If you don't know, remember this little picture. Can you see? There's the hypothalamus that we've already spoken about. There's the pituitary gland, that small little gland at the bottom there of the hypothalamus. And then as you go down into your spinal cord, just above the spinal cord, that little structure there is the medulla oblongata. All right, so it's not in the brain as such, but it's a little bit, I want to say, on the top of your spinal cord. That is where you will find your medulla oblongata. All right, let's look at a question. A learner is training for a race by running 20 kilometers every day. Describe how carbon dioxide produced in the body during training is controlled to maintain normal levels. Exactly what we've done in the 7 steps. All right, so I'm not going to go through this again in detail because you have actually looked at this. We can maybe look at this question. An investigation was carried out on a person in which the volume of air taken in at each breath and number of breaths per minute were measured at rest and after running. The results are shown in the table below. Before going to the questions, you first have to study the table. So what do we have in the table? We have in the table 2 situations. At rest, so when this person was sitting, and then just after running. So if this person was sitting, the number of breaths this person is taking is 20. And then after running, it's almost double. It's 38 now. All right. So you can immediately see when this person was in rest, the breathing was normal, slow. But after running, there is a very fast breathing. So the person is now doing this, all right, because the breathing has increased, the number of inhales. And then the volume of air per breath, when the person was sitting, it was 450 cubical centimeters. But after running, this person is inhaling a lot of air at once, now 1,000 cubical centimeters. Now let's look at the questions. Explain why the amount of oxygen taken up into the bloodstream increases after exercise. Explain why the amount of oxygen increases. Why will you have more oxygen then? Because you're inhaling faster, you have more volume of air per breath. And remember, your cells now need the oxygen. And that is why you are suddenly breathing so fast, because the cells are needing this for respiration. Then they say, describe the changes that took place in the human body to bring about the breathing rate of the person. So what must you explain here? You must explain homeostasis of CO2. So we've done that in the 7 steps. So we're not going to look at that in detail again. Question 3 is a calculation. You cannot study for this, but you must be able to read and to think logically. They are saying 20% of the air breathed in consists of oxygen, but only 16% of the air breathed out consists of oxygen. So you're taking in your air that you take in is 20% oxygen, and when you breathe out, there's only 16% of oxygen. So what is the difference? What is being used by your body? What has been taken out of that air is only 4%. And now they say, calculate the amount of oxygen entering the blood per breath after running. All right. So after running, you're taking in 1,000. So what do? You must first say, I'm taking in the air, in the air that I'm taking in, there's 20% of oxygen. But when I breathe out, there's now only 16%. So how much oxygen did my body took out of that air? 4%. All right. So it's 20% minus the 16% gives you the 4%. But now they want to know, if we look at the air that you are taking in after running, how much of that air are you actually then taking out of the air that you are inhaling? So it's 4% of that 1,000. and then we get 40. But now I know you're going to say, but how on earth do you get to that answer? Let me quickly show you here. 4% is actually 4 divided by 100 of 1,000. So I want to know how much is that from the 1,000. So when you do the calculation, if you do a calculation like that, you can actually eliminate those zeros. So with what are you sitting? 4 times 10 is 40. All right. So you must be able to do calculations in life sciences. Remember on Monday, we did look at calculations as well. And we did say that is why it's important for you to take your calculator into the exam hall. Now we're going to look at the homeostatic control by the kidneys. And remember, your kidneys are what? Your kidneys are controlling the water, the salt, and the pH. They also play a role in pH. Now let's look quickly at homeostatic control by the kidneys. This structure, I know you thought, no, you're not going to see that again. That's a nephron. And where do I find that? In my kidneys, and I have millions of them in my kidney. That is the functional structure of the kidney. It's important for you to know this structure, otherwise you are not going to understand the homeostatic control done by the kidneys. Important for you is to know that you start off with the afferent and the efferent arteriole, all right? And then there's the glomerulus, and then you have this hoop of Henle down here, hoop of Henle, and this tube here is called the distal convoluted tube, and then finally you get the collecting ducts. That's where you will find the urine. So urine will be finally in this part of the nephron. So if you don't know the structure of the nephron, I advise you to go back and make sure that you know the structure of the nephron. Because if you don't know the structure, it's going to be very difficult for you to understand homeostatic control by your kidneys. And like I've said, the kidneys is regulating 3 things. They are regulating the water level in our blood, they are regulating the pH of the blood, and they are regulating the salt levels in the blood. Now, let us first look at the regulation of water. Now, the regulation of water is called osmoregulation. All right, osmo for the water. The homeostatic control of water and salt levels in blood and tissue fluid is known as osmoregulation. Controlled by ADH, that's important, produced in the hypothalamus. Can you remember when we started, I showed you where's the hypothalamus? And secreted by the pituitary gland, that small little gland at the bottom of the hypothalamus. So it's important that you know those words. And as you study, you know, put a picture in your head. The hypothalamus is up here, and then there's that small little gland called the pituitary gland. And that is where ADH is being secreted. All right. If we look at the diagram on the left, we can clearly see that there's the normal levels that you want to obtain or maintain rather the whole time. And if the body have too much water, what is happening is the osmoreceptors in the hypothalamus there is detecting that there's too much water. So what is happening? The pituitary gland will secrete less ADH. Why? Because the distal tubule and the collecting ducts will remain impermeable for water. So the water in them will stay there and it will go to the urine. So you're going to get rid of the extra water because it's going to be part of the urine. But if your body needs water, so it's a hot day and you haven't taken in any fluid, what will you do? Or what is happening in your body rather? The water potential of the blood will decrease because the blood will now be salty. There's not enough water in it. Who will be the policeman now? Still the hypothalamus. All right, the hypothalamus is going to see, oh, there's a problem here. But what does the hypothalamus do? The hypothalamus is actually telling the pituitary gland to what? To secrete or release ADH. Okay? And what will happen now? The permeability of the distal tubule and the collecting duct and water is reabsorbed. All right, can you see there's to the structure of your nephron again? But we will look at this now into detail. So very important, you must know the structure of your nephron. And you must remember that for water, it's ADH, the hormone that's playing a role is ADH, and is being secreted by the pituitary gland, but the policeman in this case is the hypothalamus. All right, let's look at the regulation of water if we have not enough water. So there's not enough water in the body. Blood has less water than normal. Step 2, the hypothalamus is stimulated and sends impulses to the pituitary gland to secrete ADH. Important. ADH travels in the blood to the kidneys and increases the permeability of the collecting ducts. So that is what it's doing. And the distal convoluted tubules of the kidney. More water is reabsorbed. So it's already there in the nephron. So it's reabsorbed and passes to the surrounding blood vessels. The water level is then returning to normal. So it's very important for you to know that with water, with water, the hormone associated with that is ADH. All right. And the hypothalamus is going to get the stimulus, but the hypothalamus is actually telling the pituitary gland to secrete the ADH. And what does ADH do? ADH goes back to the kidney. And in the kidney, it has an influence on the permeability of the water, so of the walls of the collecting ducts and the distal convoluted tubules. And what does it do? It will actually then allow the water to go through and being reabsorbed by the blood capillaries that is surrounding them. If we look at the regulation of water and we look at if the blood has more water than it should have, all right. So that's on a day when you had plenty of things to drink and you didn't sweat a lot, so you didn't lose a lot of water. And then the blood will have actually too much water in it. What do you do? What will happen on your body that day? Because remember now there's too much water. What will happen is, once again, step 2, the hypothalamus is stimulated. Remember, where's the hypothalamus? Here in the brain. And sends impulses to the pituitary gland. Where's the pituitary gland? Just below the hypothalamus, there's that small gland, and that's going to secrete what? To stop secreting ADH. All right, because now what does your body want to do? Your body wants to get rid of the water. So the water that's now in the nephron, your body wants that to leave the body, not to be reabsorbed again. All right, so no ADH or less ADH travels in the blood to the kidneys. It's important for you to have no or less ADH is then going to travel to the kidneys. The collecting ducts and the distal convoluted tubules of the kidney becomes less permeable for water. All right, so now they're not going to allow the blood capillaries to reabsorb that water again. Less water is reabsorbed, and passed to the surrounding blood vessels. More water is now lost through what? This water will be where? This is going to be in the urine. The water level in the blood returns to normal. Remember step 7, because step 7 is always worth 1 mark. Okay. So if we have a summary basically of the water regulation of water in the body, remember with water in the body, you must remember water in the body is ADH. And ADH is secreted by the pituitary gland. And the stimulus is sent to the hypothalamus. And then what does ADH do? So ADH go back to your kidneys. And in your kidneys, what is happening there? The permeability of your collecting duct is being influenced. So either it becomes less permeable or more permeable. It's more permeable, that means more water will be reabsorbed. If it's less permeable, so less ADH was secreted, then it means the water that is in those tubes will stay there and they will finally form part of your urine. Okay, so that's important for you to have that picture in your mind, that water, homeostasis of water is associated with the hormone ADH. All right, then we move on and we look at osmoregulation, and this is just to show you where what is happening. We will look at aldosterone just now, and so what is happening here is the ADH will make they will lead, or they stimulate the permeability of the collecting duct, and if the collecting duct is more permeable, then can you see water is being reabsorbed, so the water goes out again, as well as there in your distal tubular, a little bit in your proximal tubular. And then also here in the loop of Henle, on this side, you will see a little bit of water is in here, also reabsorbed. All right. So it's important for you to know that osmoregulation is because of ADH. Then if we look at salt, the salt levels in the blood and tissue fluids are affected by the presence of solutes, that's dissolved substances. Sodium and potassium are salts that are found in the body fluids. Sodium is important in the body for good nerve and muscle function. So you must have that. That's why you must have, take in some salt in some way. Not too much, but some salt in some way in your diet. Now let's look at when the salt levels in the blood is too high. That is now if you had, let's say, a packet of salt and vinegar chips and you had nothing to drink. What is happening in your body? First of all, the salt level in the blood, I'm lying now. This is when it decreases. So when it decreases is when you don't have enough salt in the blood. The receptor cells in the afferent and efferent arterioles. All right, so now that is part of your kidney. So you must know, if you look at the nephron, where's the afferent arteriole? That's the one that's bringing the blood. And then where's the efferent arteriole? That's the one that's taking the blood away from the nephron again. The afferent and the efferent arteriole in the kidney detect the low salt level. So that is basically your receptors that are stimulated. The adrenal gland is stimulated. Now you know where's the adrenal gland. It's that little head that's on top of your kidney. All right. So that gland is stimulated and it secretes more aldosterone. That's the name of the hormone. Aldosterone increases the reabsorption of sodium ions from the renal tubulars in the kidney into the surrounding blood vessels. So aldosterone is making sure that more sodium ions is being reabsorbed. The salt level in the blood vessels increases and returns to normal. There's our step number 7. All right, so let's just recap quickly. If the salt in your blood is too low, it means your body doesn't want to lose that. It must keep that because it needs those salt for your muscle functioning and for your nerve functioning. All right. So you must keep this salt. It mustn't go out with the urines. You mustn't secrete that with the urines. So what is happening is, the first thing that you must remember is, who is the policeman here? Who's detecting that there's a problem here? It's the afferent and the efferent arterioles that you will find in the nephron. All right, they're in the kidney. They will detect that. What do? They let the adrenal gland that's on top of the kidney know that they must secrete what? They must secrete aldosterone, secrete more aldosterone. And if more aldosterone is secreted, then more reabsorption of those salts will happen. So the blood will actually take back the salts that was there in the nephron, and it will not be part of the urine that's going to leave the body. All right, let us look at if your salt levels in the blood is too high. This is now where my packet of chips is coming in. I have a packet of, let's say, salt and vinegar chips, no cold drink to drink, no water to drink. So what is happening inside my body? Because of that salt in the chips, the salt level in my blood is going to increase. What is happening? The same receptor cells. The receptor cells in the afferent and the efferent arteriole are now the policemen. And they're detecting, wow, there's now a lot of salt in the blood. So what is happening? They send a message to the adrenal gland. Where's the adrenal gland? On top of the kidney. To say, please stop secreting aldosterone, or secrete less aldosterone, because that will mean that we are not going to take back so reabsorption will be less of those sodium ions, and which means that the blood sugar, the salt will return to normal. And where will that salt now be? It will be part of your urine. So it will leave the body because it's part of the urine. Okay, so if we have a recap, please remember now then, if you're looking at salt levels, you must remember who's the policeman. It's the afferent and the efferent arteriole. They will pick it up that either the salt is too high or the salt is too low. Who are they going to tell? They tell the adrenal gland. Where's the adrenal gland? On top of the kidney. And if the salt is too high, it means we don't want it back. It must leave the body. So less aldosterone will be secreted, or no aldosterone will be secreted, which means that the salt will not be reabsorbed by the capillaries around the nephron, and it will be part of the urine that's leaving the body, and then the level goes back. If the salt levels are too low, what is happening? Same thing. Who is picking up that it's too low? The afferent and the efferent arteriole. They send a message where to? To the adrenal gland. Where's the adrenal gland? On top of the kidney. And then what does the adrenal gland do? Because we don't have enough salt, we want it back, it mustn't leave the body, more aldosterone will be secreted. The aldosterone goes to the kidney, and it will stimulate the reabsorption of those salts. So the level will go back to normal, and there will not be salts in the urine. All right, so that's very important. Here we have a summary basically of everything that is happening. So if the normal, what do we want to have? We want to maintain normal salt levels in the blood. So if the salt levels increases, what will happen? We will have stops the secreting aldosterone or less, and then reabsorption of the sodium ions will be decreased, so the salt level will go back to normal. If the salt levels in the blood decreases, what happens? Adrenal gland secretes more aldosterone. Why? Reabsorption of sodium ions increases, so we want to take it back, and then it will return back to normal. All right, this is just a summary. Then remember I said there are 3 things your kidney is responsible for, and that is for water, for salt levels, and also for the pH of your blood. Now the pH of your blood is influenced by the hydrogen ions in the blood and by the bicarbonate ions in the blood. If you have a lot of hydrogen ions in the blood, your blood will be more acidic. And if you have more bicarbonate ions in the blood, your blood will be more alkaline. So to make sure that you keep it at more or less 7, or it's about 7, what will happen? If your pH is low, so that means there's too many hydrogen ions in the blood. The hydrogen ions will move from the blood in the peritubular capillaries and into distal convoluted tubular. Less hydrogen ions in the blood will mean that your blood will return back to normal, which is 7.4. Then if you have too many bicarbonate ions in your blood, what will happen? The bicarbonate ions move from the blood in the peritubular capillaries and into the distal convoluted tubulars. Less bicarbonate ions, so it will turn back to 7.4. But in grade 12, we are not really looking at the pH control by the kidney. We're more focusing on the water level control and the salt level control in the blood. All right, let's quickly look at a question. The diagrams below show the reabsorption of salt and water through the tubulars of a nephron in the kidney under 3 different conditions. The width of the arrows represents the amount of salt and water. So don't look at the questions. Let's first look at the diagram. So the very dark arrows is the salt, and the lighter arrows is the water. All right, let's see here. Can you see here they're more or less the same? All right, so it's more or less the same salt and water. If we look at diagram number 2, you will see that more water, it's more water, this one is the biggest, and less salt. And in diagram number 3, you will see that there's a lot of salt there and less water. All right. And I know it's different. It doesn't look like a nephron, but they're just showing you here, you know, what is in the tubulus of the nephron under 3 different conditions. And then they show you that what is entering here is the glomerular filtrate with salt and water, and that's the same basically for all the diagrams. So that's the same for all the diagrams. So the output is different. So the input is the same, but the output is different. Now they're asking us, name the hormone in a human body that is responsible for controlling the water content. And you must know it by now, because we've done a lot of that, and that is what? That is ADH. And then which hormone is controlling the salt content in your body? It is aldosterone. And then they say, name the gland that secretes the hormone in question 1b. And question 1b was the aldosterone. Which gland is secreting aldosterone? It's sitting like a cap on top of your kidney. It is the adrenal gland. And then question 3 is asking us, which diagram 1, 2, or 3 would represent a person who had eaten salty chips on a hot day without any intake of water? So on a salty day, what do you want? On a salty day. On a hot day, no water, but you've eaten that chips. So what do you have in your body? Too much salt. So what do you want the body to do? To get rid of that salt. So if we look at the diagrams, we will look for one where the salt is the salt content of the urine is actually a lot. And if I look at the diagrams, it seems to me like diagram number 3, where we said there are more salt concentration or salt in the urinary bladder than water, and the answer then is diagram 3. All right, let's look at this question. This was taken from a grade 12 paper, and yes, you must be able to answer it now, because remember, you've done this. You've done the content. You're just going to add next year a little bit more to this topic. The diagram below represents one part of the negative feedback response that occurs when a person is dehydrated. What does dehydrated means? It means I don't have enough water in my body. The decrease in blood volume as a result of the excessive loss of water is detected by the brain. All right, now if we look here, they've told us we are dehydrated. And you know which hormone is playing a role in balancing or controlling the water levels in the blood is which hormone? ADH. And ADH is secreted by what? And they actually show it to you here, because if you look at this is the brain, isn't it? So if this is the brain, and you know now that it's something to do with water, then you must know it's the hypothalamus that is going to tell the pituitary gland to please secrete ADH. Now let us see. They say identify hormone X. All right, so now we know, we've already said that hormone X must be ADH, isn't it? Because that's the hormone that is associated with the water concentration in our body. Then they say identify the endocrine gland that secretes hormone X. Which hormone is which gland is secreting ADH? You must know that by now. It is the pituitary gland. And where are they going to work? Where is this hormone going to? It's going to the kidneys. And then the last question here, describe the response that occurs when a person is dehydrated after it has been detected by the brain. So now you must just say what is going to happen if there is not enough water. Then basically in the body, what is happening? You will have an increase in ADH causes the walls of the kidney tubulus to become more permeable to water. More water is reabsorbed because you want to take the water back, and the blood volume increases. Less urine is produced and the urine is more concentrated. All right, because you've taken the water back, so that's why the urine is concentrated. Okay, this question is giving us Through homeostasis, the kidneys control the composition and volume of blood and tissue fluid. The table below compares the concentration of different substances in blood, filtrate, and urine. All right, I'm sure you have seen a question like this year in your papers. They say, state what is meant by homeostasis. That's a question that you must be able to answer now, because it's the maintenance of a constant internal environment. Then we're going to look at, let's just look at question 3. It says, state the percentage of glucose reabsorbed in the nephron based on the results shown in the table. So let's look at this question. The percentage of glucose reabsorbed in the nephron based on the table shown. So we must look at glucose, it's that one. So in the blood there was 0.1 gram per 100 milliliter. In the filtrate there was 0.1, but in the urine there was nothing. Can you see there? Nothing. So how much was basically reabsorbed? All of it. So all of it, and you must put it as a percentage, is how much percent? 100%. So everything was reabsorbed. All right, the same one here, that's just another question that is actually saying, you know, you have to describe the role of aldosterone, actually ADH and then aldosterone. I'm not going to go through that now, because I think we have really took time to look at, you know, the control of water and salt in your body. And now the question is, if I must know all of this now, what will I do in grade 12 on this topic? And in this topic, you're only going to add 2 things. So you've done, I want to tell you, more than 2/3 of the topic already in grade 11. So what are you going to do next year? You're going to learn about temperature regulation in the body. How does the body react on a hot, on a cold day? And you're going to look at your thyroid gland that is situated here in your neck, and then the secretion of thyroxine that plays a role in our bodies. And that brings us to the end of today's lesson. What is very important, grade 11s, is you have to go back to this chapters in your grade 11 work. Remember, you will not find a chapter that is going to say homeostasis. You will have to go back to your digestive system and go and look for homeostatic control of the glucose levels. Then you must go to your breathing system and go and look for homeostatic control of CO2 levels in the blood. And then you must go to excretion by the kidneys, and there you must go and look for homeostatic control of salt and water, especially in the blood. All right, so in your grade 11 work, it's not one chapter that this is coming from. You have to go and select from those 3 chapters the homeostatic control that is very important for grade 12, because a lot of marks is allocated in the grade 12 papers to this topic. So make sure you are well prepared for next year and make your life in grade 12 2022 so much easier. Thank you for watching this lesson today. Please remember, sanitize, wear your mask, and keep your social distancing. Have a nice day, and go back to your life science textbook and make sure you are on top of homeostasis. Thank you.